Scale, quantity, proportion, models of the atom. Our objective today is I can draw a model of the atom with correct scale, quantity, proportion, location, and charge of subatomic particles. As a reminder, the subatomic particles are protons, neutrons, and electrons. The scale is the size of something compared to something else. For example, this is Joby. Joby has a watch that is about the same size as his eyeball. But what if Joby were bigger? The size of the watch is still about the size of his eyeball. If Joby were even bigger, would his watch still be about the same size as his eyeball? Even if Joby were gigantic, his watch would still be about the same size as his eyeball. That's scale when you compare sizes between two different things. The size of something compared to something else. Here's a question to consider. What is the scale of Joby's watch compared to his red shirt? Would it still have that same scale if Joby were smaller? What is the scale of subatomic particles? A proton has 1 AMU. That's its size. An AMU is an atomic mass unit. So a proton is 1. A neutron is also 1 AMU. An electron, however, is 1/2000th of an AMU. So it is way, way, way smaller than a proton and a neutron. So if a proton is a size and it grows bigger, a neutron would be still the same size as that proton. But if the proton got bigger like Joby did, electron would get bigger, but compared to the proton, it would still be much, much smaller. So if a proton is Joby's shirt and the electron is Joby's watch, doesn't matter how big Joby gets, the scale will stay the same. If an electron was as heavy as a penny, a proton would be as heavy as a bowling ball. So even if we made them bigger, the electron scale would still be much smaller than the proton. Quantity. Quantity is the number or amount of something. Here is 1 Joby. That is the quantity of Jobys on this page. Here are 2 Jobys. The quantity of Jobys here is 2. Here are 3 Jobys. Wait, is the quantity still 3 even though the third Joby is a different size? Yes. Quantity is all about how many or how much, not about the size. What is the quantity of Jobys here? Well, there are 4 Jobys, even though one is so big it doesn't fit in the picture anymore. Still 4 Jobys. Here's a question to consider. What is the quantity of legs in a picture with 3 Jobys? The quantity in the atom. The quantity of protons determines which element the atom is. This is called the atomic number. So if there is 1 proton, it is always a helium. It is always a hydrogen. If there are 2 protons, it is always a helium. The number of protons determines what element it is. The quantity of neutrons is the atomic weight minus the quantity of protons, which is the atomic number. So atomic weight minus atomic number is the quantity of neutrons. The quantity is the number or amount of something. Proportion. Proportion is the part or number of something compared to the whole. For example, how many watches per whole Joby are there in this picture? We have 1 watch per Joby. But what if we have 2 Jobys? If there are 2 Jobys, there's still only 1 watch per Joby. So there are 2 watches on this page, but since there are also 2 Jobys, that is 1 watch per Joby. If there are 3 Jobys, it is still 1 watch per Joby. How many watches per Joby are there now? It doesn't matter how many Jobys there are. There is 1 watch per Joby. Here's a question to consider. How many eyeballs per Joby are in the picture with 3 Jobys? Proportion in the atom. The quantity of protons determines which element the atom is, as we talked about, but the proportion of electrons is 1 electron per proton. So there are the same number of protons and electrons in every neutral atom. Same way, there's the same number of watches as there are Jobys. No matter how many Jobys there will be the same number of electrons per proton, no matter how many protons there are. Remember these quantities and proportions with the acronym APE-MAN. So our proportions, atomic number, A stands for atomic number, P stands for proton, E stands for electron. All APE are equal in number, in proportion. So they're all equal in proportion. Okay, so same number. The atomic number is the number of protons, is the number of electrons, 1 to 1 to 1, all the same number. The quantity, the mass number, and the atomic number and the neutrons spell out man. And the mass number minus the atomic number equals the number of neutrons. That is a quantity. So a proportion is the part or number of something compared to the whole. Here's a review of some things we have already learned. This is the charges and location of subatomic particles. For this subatomic particle, the proton, it has a positive charge and it is located in the nucleus. The neutron has no charge and it is also located in the nucleus. The electron has a negative charge and it is located outside the nucleus in what we call the electron cloud. Your turn. Draw a model of a sodium atom with correct scale, quantity, proportion, location, and charge of all the subatomic particles. You can see this is a periodic table version of sodium. It has an atomic number of 11. It has an atomic symbol of Na and an atomic weight, which is the average of all the known atomic weights, of 22.99. Use the information you have learned to draw a model of the atom. In your model, you're going to use symbols for protons, neutrons, and electrons. So instead of just a circle for each one, I'm going to have you create a symbol. You could use stars for the protons and squares for the neutrons and circles for the electrons, or whatever symbols you want, but you have to show me a key. So somewhere on your model, you have to say protons equal stars and neutrons equal, I don't know, whatever you want to do, octagons. So you have to have a key so that I know which shapes are which particle when I'm grading this. Your objective, I can draw a model of the atom with correct scale, quantity, proportion, location, and charge of subatomic particles.